Hello, everyone. So I want to give Dominique here a very warm thank you for inviting me to speak tonight. I appreciate it. This is my first time in London. I've been here for about a week and I've enjoyed the city so far. I'll be sure to come back at some point, I'm sure. So this is my talk. This is the title, Microservice Observability. And really it's just the idea of coming to a better understanding of how our environments work and how microservices operate in the wild. And that's what we're going to cover tonight. So if my remote would work, this is why I don't like Google Slides. Here we go. All right, so aside from the giant picture of my face, I do developer relations at Instana. We are an APM application performance monitoring company. I work in the education awareness area. That's the whole developer advocacy part of the job. And I also work on the product focus for SRE type topics, things like artificial intelligence, as well as alerting and management, things around SLIs and SLOs. And I kind of help our product team understand what the needs are of DevOps and SRE type personas in our company. I also contribute to open source, whether it be creating demo applications or workshops, as well as applying any kind of changes upstream. And I've done some work with Terraform as well in the past. So when I'm not doing the developer relations, I work on a small startup called Single Music, and I'm the principal SRE there because I am the only one. So my role there is as a co-owner and a consultant. I built the delivery system on Docker Swarm a few years ago, and it kind of just works, which is the beauty of Docker Swarm. And since then, I really just make sure things don't catch on fire, or if they do, that I can put that fire out. So that's where the maintaining production excellence comes from. I've been doing software in some shape or form for around 20 years. I learned about Docker in 2014 after watching a video of Solomon at PyCon, and I was like, okay, that looks awesome. And I put it into production the next year. And since then, I've been named a Docker captain, a GitLab hero. I run the Nashville Docker meetup as well as the Nashville DevOps days as well. So it's just a little bit about me. If you want to follow me on Twitter, there's no way I'm catching up with you, Dom, so no threat. So what we're going to talk about this evening is what observability means, what that term has come to encompass today and over the past, 50 years. What is distributed tracing, how that plays a role into it. Also, really what the monitoring landscape looks like today. And finally, we're going to talk about how we use these tools at Single Music. So observability, theory, and reasoning. Observability is actually rooted in control theory, which was a paper that was published in around 1961. And this dude told us that a system is observable if the behavior of our system can be determined by just looking at its inputs and outputs. The lesson that we should probably take away from that, though, is it's well documented. And it's a valid approach for figuring out how our systems work. And even back then, they had really complex math theories to determine how observable these really complex systems they were building. I mean, this is the kind of stuff they use to go to the moon. So if they can do it, we can do it. So what observability should enable us to do in modern architectures, it should enable us to find patterns. It should allow us to assign sub-significance to those patterns, help us reason about them, and finally, give us some guidance on how to act on it. Like what do we need to do with this data that we're collecting? Colloquially, I like to say that observability is looking, monitoring is seeing, and then controllability is acting. And the reason we need this is because as we adopt those microservice environments, as we adopt these new patterns of architecture, serverless as well, the rate of change and the complexity ramps up. And really our only choices here are to either adapt or collapse. There's no real right in the middle ground. And they talk about that quite a bit in the DORA State of DevOps report and with the J curve of transformation. So how many here runs the staging environment? A few hands, yeah. How many of you actually trust it? Right, not as many hands, right? And this is why, because our users run rampant in our production environments, and it's really hard to emulate that in staging. It's not impossible, but a lot of us have many other things we could be working on than trying to get this in staging. So distributed tracing is this observability. Now, it's maybe, I don't know. I would argue no, it's not. It's definitely, you know, observability is not sex education, by the way. We do have a mirror on the ceiling, though, for whatever it's worth. So what distributed tracing is, what's the abstract, right? And in 2010, Google wrote a technical report about Dapper, which was their distributed tracing solution. And there's a lot of text up there, but what it's basically saying is that as they built out these large, complex environments that was built by different teams using different programming languages and could span many thousands of machines across many physical locations, that they needed tools to help them better understand and aid in the performance issues that were coming up. So if we start talking about, well, how does distributed tracing work? It's pretty simple. And I'll break this down a little bit further in the next couple slides, but essentially every request that our system generates, and that could be a transaction from REST API, gRPC, RabbitMQ, Kafka, you name it. Anything that makes a transaction across the network, we are attaching headers or information to it that helps us correlate it. So what we can see up here at the top is we have a front-end request. That's the initial request. And we have no parent ID on it because it's parentless. It is an orphan. And then we have a span ID, which is uniquely generated for each individual transaction. Down here at the bottom, we have a subsequent call, and that back-end call is maybe making a request to a database to get some information, but we give that its own span ID and then assign it to a parent, which is the one that happened before it. And then so on and so forth. It just goes, you know, it's all turtles, right? So that gets visualized into a Gantt chart. And another way to look at this is it's just simply we're tying a bunch of transactions together. And on the other side of it, we're collecting that data from those transactions and those headers, and we're stitching everything together. We're making correlations. And what that'll look like is something like this, where we get an idea of the individual endpoint, what was called, what the timing of it was, and also we get some other rich information like, was there an error? Or what was the stack trace if there was an error? So what do we get from all this? We get a ton of telemetry, which is great for aggregation. It's great for machine learning. It's also pretty good for performance analysis and debugging, but it also creates a giant data lake where we drown if we don't know how to manage all that data. And that's where we're kind of at in the current ecosystem. So let's talk about that a little bit. We have legacy tooling. Many of you probably are used to being exposed to that. Things like Nagios, StatsD, SNMP, Zabbix, those type of tools. Those are really just completely unsuited to handle the rate of change these environments are going through today. And then we have modern open source, which is actually getting very well equipped to handle that type of change. We have Prometheus operator now. We have a Jaeger operator as well. And these things will almost just auto-wire themselves to start collecting that data for you. But it doesn't address the data lake problem. We still have to analyze that data. We have to create these buckets. We have to roll up. We have to create these logical units of information that we can act upon. And then, of course, you know, I personally don't want to hire a bunch of data scientists to figure this out. I want them working on my business problem, which is where we start talking about vendor tools. And I don't want to pitch, but the idea here is that if you want to get that value out of the data, you're either going to build it yourself or you're going to pay somebody else to build it. There's really no, right now in the current ecosystem, there's no getting around that. So how do we get to this state, right? Because when we talk about monitoring currently, what we do is we shove a bunch of data into a database, into a table, and then we build queries and we pull that data out and we visualize it somehow. But what we really should be looking at and trying to wrap our head around is combining all this data. We still need to query this data. We still need to collect it, and we still need to put it somewhere. but then we need to bring it all back together. And this is a Venn diagram from Peter Bourgeon, who wrote this in 2017. And he said that if you bring all of them together, what you ultimately get is what's called request scoped aggregatable events. And I'll explain what that means. But in summary, and if we're take it down to layman's term, it means we're not treating services like Schrodinger's cat. We're not just throwing it in a microwave, right? Is it alive or dead? We have a lot more context around the interactions and the transactions of our system. We can generate interactive dashboards that allow us to really dive into the data. And I'll show you what that looks like in a few slides here. So how do we get that though? Like, how do we build that? Well, we create these individual buckets of data, right? And we can scope them based on things that we logically connect them to, things like groups of services or groups of applications. And then once we have that, we can roll up golden metrics. We can do things like, well, what was the mean latency across all those services or all those endpoints in that service? And then we can also do things like, well, what's the throughput? What's the error rate? And that's what we call golden metrics. And that's from the SRE handbook from Google. And that will help us really ascertain the health of a service pretty easily. It's not all that we take into consideration, but it's a pretty good indication. If our service is rocking the throughput, has good latency, like low latency and really low error rate, we can kind of assume it's probably healthy, right? So what do we get if we start taking this approach to our monitoring? Well, we get the ability to alert humans when the machine detects there's a deviation or an anomaly. We can also build those summary dashboards, those interactive dashboards that let us immediately bubble up those indicators that there's a problem, and we can go dive into it. And again, we can use machine learning. So Single Music, how and why we use observability tools. So Single Music, it's a company that I started with a couple friends a few years ago. We haven't really grown the engineering team, even though we've grown the company significantly. We've had about 400% growth. At peak periods, we roughly run about 20,000 transactions per hour. That's not sales. Like there's a little bit of ambiguity in that term, but it's generally how many interactions our system has internally to process our workload. We have over 20 integrations, about 150 lines of code up to this point, and we're able to operate with a pretty low test coverage percent. And I bolded that because most people talk about, I've got 90% test coverage. Screw that, I got 15. That's awesome. So we launched in 2018 with 15 microservices on Docker Swarm. We're up to 40 now, I think, and we haven't had to add new personnel. And that's because we built a one-touch deployment system and a provisioning system so that the developer on the team could just declare a new service and off he went, because I'm super lazy. Like, I don't want to do anything. So the more I can let him do, the happier I am. And we have roughly around 10 to 25 deploys a week, sometimes more, sometimes less. Who knows? And we have some pretty big bands, right? Y'all might have heard of some of those. This couple weeks ago, Tool put out a new album. We had Lana Del Rey, and we also had somebody else. But we were like responsible for doing sales for 3 of the top 5 Billboard artists. And we're able to do that because we have some pretty good monitoring in place. So what does Single Music do though? Like yeah, I get it, you guys are growing and you're awesome, but what do you do? Well, we do digital music sales and physical music sales reporting. We do fulfillment and distribution as well. We do sales tracking, landing pages, analytics and reporting. We have integrations with a bunch of stuff so that people can kind of socialize their music. So how do we visualize? How do we monitor this? Right. What I'm going to show you next is a 3D diagram, and each individual stack that you'll see here is a host, and within each one of those hosts, you'll see little pancakes or stacks of containers, and I'll explain from there. So here's the representation of our infrastructure. AWS, we have multiple availability zones. I just switched to a production view to look at our production containers. I'm clicking on a host here, and I can see all the details about that host, as well as what's running on it. So Spring Boot applications, some Elasticsearch, some random stuff. now I'm opening a dashboard that's showing me the metrics for that service. So I can look at things like what's the thread count, what's my garbage collector doing, what's happening with my service. So it's pretty simple, easy way to see the general health of my system, because if Instana detects any problems with any of those containers, things like high CPU load or memory getting close to that container limit, it's going to turn yellow. And if it is really unhealthy, like it's throwing a ton of errors, it's going to turn red. So this is a diagram of all the transactions that are actually happening in our system in real time. And these are, as I said, these are broken up into those buckets, right? So individual services, and each one of their transactions are represented, and I can see those golden metrics. I can see the call rate, the error rate, as well as the latency. And now this is all generated dynamically on the fly based on all the data that's getting pushed into Instana. It's a lot of data. So how do we, that's great and all, but how do I use that? How do I get information out of that? And we do that because we have these interactive dashboards which roll up all that data. So what we can see here is we have a summary dashboard of all of the services that are running in my production namespace. Again, this is Docker Swarm terminology, but you could easily apply it to Kubernetes or anything else for that matter. Up here we have the throughput, which is essentially a representation of all the calls that are coming into my service over a period of time. This is over 12 hours. So we can see a histogram of really the how busy my services are. And then we can also see a histogram of the errors. Plus we can see the latency percentiles and the processing time. So this gives us a couple different things. And I want to unpack that because we have up here at the top, 50, 90th, 95th, and 99th. And what that is like, what that tells us is with the 99th percentile, that means that 1% of my requests have a latency in that purple line. So what that's telling me is that some of my requests are a lot slower than the other ones. And this might help me understand that there could be an indication of a problem that is kind of just waiting to unveil itself or reveal itself. And this helps really kind of understand where in my system there might be a problem, because if all you're doing is you're looking at the average latency, this is going to get swallowed, right? The 99th percentile is going to get wiped out because 99% of the other requests are doing just fine. On the bottom, we have processing time broken apart by database, as well as messaging system and the HTTP, so REST API. The next section is where we can do some troubleshooting pretty quickly. And over here on the top, we have these little buttons that we can click on that will actually change what is represented here. So if we click on calls, it would change to show us the busiest services essentially. Or if we clicked on errors, it would show us the services that have the most errors. And if what we're interested in is the most latent, I can see that the SoundScan service is showing me that for the average latency, it's serving around 930 milliseconds. I may want to go dig into that. What would that look like, right? Well, it would look very similar to this, but I would have individual traces for that service rather than multiple services over here on the right. So the same thing applies here, where each one of these endpoints tells me how busy or how erroneous a particular service is. So this is that Gantt chart I showed you earlier, but like legit. Like this is somebody creating a new product line in their store, and we're gonna kind of unpack what's happening here because it's quite a bit of stuff. So up at the top, we can see that over 2,000 interactions were made to complete this transaction. And within that 2,000 transactions, there were a few errors, right? We detected that there was some error logs generated in our code as well as warnings, and that actually one of these transactions, one of the 2,041 transactions came back with an error code. And that error code could be something like a 500, or it could be a database transaction that came back as an error. And then we also have the figures around latency and the call duration. And let me explain what the difference between those are. Latency is a measure of how long it takes for a transaction to be fulfilled to the client. So on here on the left-hand side, we can see that this transaction came in, a post came in to this endpoint, and it wrapped up around 35 seconds. But then underneath that, a bunch of other stuff happened. And this was because our system is built on RabbitMQ, and we do a lot of work asynchronously behind the scenes because this work down here in the lower corner isn't necessary to fulfill that request to the customer. So this tells us that, yeah, the customer's request fulfilled in around 30 seconds, which is probably kind of slow, like maybe we can fix that. But most of the work is taking over 2.5 minutes to finish. But that's important to know because there's a lot of stuff that happens in here and we want to know if something breaks. And in this case, something did go wrong, right? We can see here on the corner here that there's a red exclamation mark and a marker. And if we click on that, we get taken to the actual details of that transaction. And we can see that a request was made to some kind of dispatcher or handler. It was put onto a message queue and then consumed by a service. And on the right here, we've collected the details from the database where we can see that, well, it looks like there is a duplicate entry. And in this case, it was just an item potency error, right? Because we didn't check that this hadn't already happened by some other worker. And that was the case here, is that work had already been done by something else. So it wasn't catastrophic, but it was still something we want to know about and that, well, we can easily fix. Now, where I think the future of monitoring is going is that while I just told you what the problem was, we had to go investigate that, right? We had to go look that up. What I'd like to see in the monitoring in the future is that this system would detect that this query had already happened in this transaction and could tell you, you have an item potency problem. Here's where it already happened. So I didn't have to do that investigative work. We're not there yet. We're working on it. But again, this is where my feedback to the product team is really instrumental in kind of building out that kind of features, those kind of features. So in this next slide, again, we have a summary of all the services within the production application that we're running up here. And this gives us an indication of what the technologies are, what the domain of these individual services are. So things like what frameworks it's using. Is it a database? Is it using the messaging system? Is it running batch jobs or is it running serial type jobs? And then we get the complexity of them. And the number of endpoints in a service is a good indicator of how complex something is, because the more endpoints you have, the more responsibility it has, right? Because if we associate endpoints with work, then the more endpoints there are, the more work the service is going to do. And this could help us also kind of determine when do we refactor? When do we start splitting up these services into smaller services or functions? And then, of course, we have the golden metrics, as I mentioned before, throughput, the error rate, as well as the latency of it. And then finally, the indicator of health, which is a factor of many things, but we're looking at things like, is the throughput healthy? Is there a big drop that just happened? If there is, then that might not be healthy. As well as like the error rate. Was there a sudden spike in errors? And this is where the machine learning comes in, because if we analyze all of this data over time, we can do something called change point detection, which will help us do factors or factor in the probability of an issue, right? So how do we use tracing in a more holistic way? How do we help it understand our architecture? Again, this is an asynchronous transaction. At the top, the request is fulfilled, and then we have individual tasks being done underneath that. But we can also look at the individual ones and visualize things like patterns in our algorithms. So we can easily visualize things like exponential backoff. And we're also able to solve problems. You can see here on the right-hand side where we have a slow rise in latency. And this was brought about because we had we built the transaction system in a way to where every single transaction that was generated in our system would load all the other transactions. And that caused a problem, right? O(n) log n, rise in latency. And all of a sudden we were a real risk of actually breaking our system. However, because we had this in place and we could see that, we deployed the fix and the problem was resolved. This was the other thing that we noticed too, is we had some blocking actions in the Gantt chart we were looking at. And this was from interacting with auth0, and we would go and request a token every time we would kick off a new thread or a new worker. And we were like, well, what if we just cache that, right? Well, we did, and it fixed the problem, but what we didn't account for is 6 months later, auth0 changed their policy around after about 30 seconds, that token would expire. So we had to go get a new one. And we caught that because that Gantt chart showed that around 30 seconds, we had a ton of errors coming in. And we were alerted to it, and we were told what the error was from the solution. We were told, okay, well, here's the error log and the parameters of it. And then we were able to fix it. So you can see here that past 30 seconds, the transaction does just fine. So this next slide I'm going to show you is us looking at a list of those errors or some errors and being able to jump to the trace. So we have error messages. We're able to jump to the traces, and we're able to quickly investigate the whole context of that issue. And the point I'm getting at here is this really plays into that Venn diagram that I pointed out earlier, where we have logs, we're able to jump to the trace, and then from the trace, we're able to jump to the backend infrastructure and look at the metrics at that time. So say we had a garbage collector going crazy that caused the system to slow down and time out, and that created a log message. Well, we can investigate that very quickly if we connect all those pieces together. So we're able to also build custom dashboards, and we're using Grafana because we do have a plugin for that. And these dashboards took me around 5 minutes to build. It wasn't too terribly complex. And it's all because we were able to pull that data just directly out of Instana. So just to summarize everything we covered, which is quite a bit, the first thing I want to point out is microservices really helped us meet the needs of our customers because we're able to scale and build very effectively and very rapidly. We were able to really embody the DevOps methodology and practice and culture. And secondly, observability tooling has helped us maintain that production excellence, making sure that if there is a problem, we know about it before our customers come and yell at us at Twitter. And then we're also able to, so that means we're able to focus on the problem at hand, which is making sure that we can deliver the music to the customers and make our the bands and the artists happy. So that's great and all, but I don't want to spend money on this. So what do you recommend, right? Well, first thing I'm going to recommend is you use tools that allow you to leverage distributed tracing and things like Prometheus and logging. Because later, that's really going to make your life easier if you have those practices in place. Because if you're using those types of tools and those types of practices, then adopting a managed solution doesn't become such a large ask later down the line. At a minimum, I would recommend you do a POC with open source tooling, things like Jaeger, Elastic, as well as Prometheus, and I don't know, there's a ton of them out there, right? But the point here is that you understand the problems you're trying to solve, as well as what kind of value vendors are going to bring you. And we're not the only monitoring vendor, right? There's plenty of them out there. Ultimately, though, share your success. Talk to people about what you're doing and how you're doing it and the problems you're solving. Because ultimately, most people aren't even aware that this type of functionality exists, right? That you're able to dive that deep into your system. So with that, I think I have about 2 minutes or 5 minutes for questions. So I'd love to answer any questions you'll have. That's a lot of stuff we just went through.
I mean, a little applause is fine.
Yeah.
Any questions? Last time for a little exercise?
Yeah.
I'll go on then. Oh, doing the double steps.
Hi. So in order to get this level of observability, do you need to build some of Instana software into your code, or can you do that with just the metrics and logs that your software already provides?
Okay, so there's two parts of that question, and I'll answer one at a time. The first one is, do we need to build additional code, or do we need to create additional instrumentation in our code, right? And the answer is it depends. And it depends on a couple of different factors. One is the language and the framework, and also your architecture. So Single Music is all Java based, and we have some Go services as well, but that's mostly to manage the delivery pipeline stuff. But with Java, because of the way that language was architected and built, Instana can actually connect to the process at the host level, right? Once it connects to the process, it can inject through a byte loader the instrumentation package. And once that library is loaded, it then wraps around all those communication methods and does the instrumentation for you. So what that ultimately means is, like, within literally 5 minutes, once I had the agent on the host, it was able to automatically instrument all my services and give me all that information that we just saw. Other languages aren't as forgiving. So if you look at something like Go, like you're gonna have to import the library at a minimum. And then depending on what frameworks you're using, like if you're using Mux, we're gonna auto wrap that. But if you're using some home baked thing, like where you just kind of made it yourself, then you'll have to use the SDK to actually instrument. Again, it's a complicated answer because there's so many variables there. I don't remember the other question. Sorry.
Can you get some level of observability with just the logs and metrics that you?
You can get some basic information, but one of the things that Instana does that I think is pretty cool is with that information we gathered through tracing, through all those individual transactions and all those timings and the response codes, we can assign health to that data, right? So if you don't have distributed tracing, you can't do that, right? So that's the challenge. Now, if your system isn't as complex as what we just looked at here, who cares, right? But if you're looking at an environment where you have many microservices, you probably want distributed tracing. It's kind of like you have to have it almost. You're welcome.
Cool. Now I'm up here. Any other questions?
Got one right here, Tom.
Oh, I'm gonna
No.
sneak up on the back.
Okay.
That's probably easier.
Right behind you.
Surprise.
Surprise.
All right, thank you. So you already mentioned how you guys integrate with Java. What is the exact integration and support for Python?
Very similar, I think. If you look at, it's all in our documentation, and I don't necessarily want to jump there, but I believe with Python, we have the same level of functionality with Python 3. Probably. I'm not 100% sure. At a minimum, I mean, like in most cases, you can get away with just introducing the library in the code yourself. And then once the library is there, it does all the other work. Unless you're doing something like you're communicating over WebSockets, which God help you. But if you're doing something like that, then you obviously have to collect that data and pass it through the WebSocket as well. Or if you're doing direct TCP connections. But as long as you're using technology in which allows you to use headers or some type of metadata, typically we just automatically trace that stuff. Yeah, you're welcome.
Cool. Anyone else? Oh,
I just wanted to ask something. You just mentioned Python.
Yeah.
I mean, the live stream wants to probably hear it too.
Yeah.
Thank you very much. Python integrates very well with the JVM of any web application, actually. It's part of the framework. It's an interpreted language, a passive language that sits on top of the JVM. You can, remember that the JVM itself, the Java Virtual Machine itself, is not really Java agnostic per se. It accepts other languages, other passive languages that sit on top of it. So in my experience of moving a client onto the Azure cloud itself, Python sits extremely very comfortably with the JVM frameworks offered by Spring Boot. So that wouldn't be a problem at all.
Was that a question for?
My question was about, you mentioned about Prometheus.
Yes.
Prometheus is a monitoring tool for my experience, is just a reactive tool. It doesn't proactively monitor the instances of failure. It doesn't warn you ahead of time. It just tells you when something has failed.
Yeah, absolutely.
Okay. Is there? Well, does the Instana? Does Instana is the preferred solution you were offering? Does it proactively monitor the instances to warn you ahead of time?
I couldn't quite understand you. I'm sorry.
The monitoring tools is available at this moment in time from Helm. Looking at your examples we were using was on Docker Swarm.
Yes.
Okay, we're using the AKS service.
Yes.
We're using Kubernetes with Prometheus.
Right.
Prometheus does not have the capacity to proactively monitor failure. It reacts.
Yeah, absolutely.
Which is not helpful, because you want a monitoring device to be dynamically, proactively looking at instances potentially for failure.
Right.
So you can take reactive action. You don't have to wait for it to fail. Then everybody starts complaining. What other solutions, what other technologies do you think are out there that can proactively go around looking for the instances in the microservices environment to detect failure before they happen?
Well, I think that's where distributed tracing comes in, because you're essentially collecting data on everything, and it's a tricky proposition, because when you collect that much data, there's always some level of overhead. But without that information, then how can you be proactive about your environment and your situation, right? So if you're collecting data about all those individual transactions, and all of a sudden you have the data's there, you just have to know how to look at it or how to find it. That's where managed service providers such as Instana, and again, there's other ones out there too. You got Dynatrace, Datadog. Yeah, I mean, like they all have some measure of intelligence when it starts when it has all that data. It can start looking at it and making some general assertion about the well-being of your system, right? So I think there's room for growth with the open source tooling out there to help bring that level of visibility, but I think we're still several years out before that is a realization. Yeah.
Cool. All right, on that note, I think it's time for the pub.
Yeah,
Give a great round of applause to Kevin coming all the way from the States. And to Mark and to Carlos for doing amazing talks as well. So that concludes the September edition. Whoop. Where's Jonathan? John? Is he still there? Okay, so John said to go to the porterhouse. If everybody could follow him to the pub, I'm sure there'll be some. I think they're turning off lights and stuff. I think we need to go. Okay, so lift, 3rd floor, porterhouse, have a drink. See you next time. Bye.